All right, let's try doing notes together. This is for 11.4, and it's about, does a multivitamin improve memory? So we have researchers from Harvard and Columbia wanted to know if taking a multivitamin improves memory. To investigate, they took a whole bunch of volunteers and randomly assigned half of them to take a multivitamin every day and the other half to take a placebo. Here are the summary stats for the scores on the memory test the subjects were given at the end of 1 year. Then they're asking, is there convincing statistical evidence that multivitamins improve memory? Use an alpha level of 0.05. So this is us just walking through, is this a 1 sample or a 2 sample? And this is definitely a 2 sample. We got a sample from Harvard and we got a sample from Columbia. So this is a 2 sample. Then the next question is it a Z or T? And since this one is for means, this is a T. Then the next question is this an interval or a test? Since they asked for convincing statistical evidence, that is a test. And this is for means, so we would say for mu sub 1 minus mu sub 2. Okay, and then our parameter would be defining those two things. So we have mu sub 1 minus mu sub 2 is the true difference of mean memory test scores. And we're doing multivitamin minus placebo. So we're giving them the order that we're subtracting them in. Okay, otherwise significance level, we've got alpha level equals 0.05. Our statistic would be our x bar 1 minus our x bar 2. And in this case, this would be our 62.4 minus 61. And that would be equal to a positive 1.4. Then we go over to our hypotheses. So we have our null hypotheses as are they equal? Okay, and then we bring one of them over by subtraction and we get mu1 minus mu2, is that equal to 0? And then our alternative is we're looking at mu1 and mu2 and they're looking for, does it improve memory? So we're looking to see, does the first option give us a higher mean than the second option? Does the multivitamin give us a higher option than the placebo? Right, move those over, we get mu1 minus mu2 is greater than 0. And then we're looking for, well, do we have any evidence at all? Well, since our statistic already gave us a positive, we do have some evidence, right? Yes, because x bar 1 minus x bar 2 is already equal to 1.4, which is positive and greater than 0. So that is looking like it's good. Now the next question is, do we have enough to actually prove it doing the statistical test? All right, so we have some things to check. The first one we have to check is our random condition. So we're going to go back and look for the word random and quote it if we can. It looks like they randomly assigned, right? So we have randomly assigned. Randomly assigned is stated in the problem. And remember, what does that give us? That allows us to, because we're randomly assigning, this is an experiment. And because it's an experiment, we don't just get to apply it to the population. That's random sampling. Random assignment is the one that gets us, so we can show cause and effect, or you can just say we can show causation. Okay, so next one, 10% rule. 10% rule we don't need to check because it's an experiment. Remember that this is only for sampling. Okay, and then our next one, our last one, is our normal or large count. So on our large count, we are looking at, did they say the population of either one of them are normal? And I don't see anything when I was reading that said normal, so no. Then we go and we check central limit theorem. Is N1 greater than or equal to 30? Our first group was 1,781. So that looks like it is good. And then our second group also has to be greater than or equal to 30. Well, they're the same amount, so those also pass. Okay, and then why do we check this one? It's the reason that we do this is so the sampling distribution, of x bar 1 minus x bar 2 is approximately normal. Okay, so remember, if we're doing random assignment and it's an experiment, we don't need to check that 10% condition. All right, next one, calculate. So we're going to write out each one of the formulas. So our first formula, general formula, this is going to be how do we get to our t. The most generic is the test statistic is equal to your statistic minus your parameter all over the standard error. Okay, so our specific formula is t equals x bar 1 minus x bar 2, and that's minus mu1 minus mu2, and that is all over our standard error, so that's going to be s sub 1 squared over n1 plus s sub 2 squared over n2, and that is all underneath a square root. Okay, and then when we plug in numbers, we're going to have t equals, and we have 1.4 minus our null hypothesis. Remember, we said they were equal, so we said the subtraction is 0. And then on this side, we're going to be doing the square root of 18.4 squared over 1781 plus 18.7 squared over 1781. And that's going to give us about 2.25. All right, so taking a look at our picture. So we want to draw the normal curve. We want to identify it as normal. Okay, and let's see what we can do with this one. So we said that the typical t-score would be a 0 if we subtract them. So a t-score would be a 0. 2.25 for a t-score would be right about here. So we're looking for that amount. And how much would that have been originally if we were actually doing a number? We said that that was where the 1.4 was, right, as an actual subtraction. Okay. All right, so this is a normal with a 0 as our middle. And then what's our standard deviation? Well, our standard deviation is going to be everything that is under here. Okay, so everything that is under here is what's going to become our standard deviation. So give me a second here, and we're going to go calculate that. So the square root of, and we're doing 8.4 squared divided by 1781, and then plus, and then 18.7 squared divided by 1781. And I am getting that that amount is 0. Oops, let me go and change that to an actual color. So I'm getting that that is 0.621, something like that, okay? Now, we also know that this is a t distribution, right? So we should also be saying that this is a t distribution. And in a t distribution, we really just need degree of freedom. So in a normal, if it was a regular normal one, the 0 and the standard deviation is great. Okay, if we standardize it to a t-score and we're just using the stuff on this bottom row, then all I really need is to say it's a t with its degree of freedom. So I don't need to write the n anymore. I'm writing a t, and that one only requires degree of freedom. So how do I figure out degree of freedom? Well, that's going to be the unusual one, right? Because to figure out degree of freedom, we know degree of freedom is equal to n minus 1 of the lower of the two groups. And so they're both the same amount, 1781 minus 1. So that would be 1780 if I'm doing it by hand. So 1780 is our degree of freedom. Okay? So our test statistic is t equals 2.25 with a degree of freedom of 1780. And then if I put this into my calculator, I'm going to be doing t-CDF from 2.25 to infinity. So second vars, t-CDF, that's number 6. And we're going 2.25 to 10 to the 10th, and then the only thing they ask is degree of freedom. So 1780, I've already subtracted my 1 and hit paste. And it is giving me degree of freedom is 1780, and that's giving me 0.012, so a little bit more than 1%. Okay, so our conclusion. So we start out with our conclusion of what does a p-value mean, and it says assuming the null hypothesis is true. And what does that mean? It means that mu1 minus mu2 is equal to 0. There is a 0.012 probability of getting x bar 1 minus x bar 2 of 1.4 or more extreme. In this case, it would be or greater, purely by chance. Okay, so that's sentence 1. Sentence 2 starts here, and we say because, and this is where we're going to compare, because our p-value, and our p-value is 0.012, and then we compare it to our alpha level, and our alpha level was 0.05. This is a less than, so our decision, we reject HO. Anytime we reject, we do have convincing evidence. We do have convincing evidence that, and then we go back to what was their question. Their question was, do we have convincing statistical evidence that multivitamins improve memory? So we can say that multivitamins improve memory. Okay, based on your conclusion from the significance test, which of the two errors, type 1 or type 2 error, could have been made, and interpret your consequences. So what did we do? We rejected HO. If we did it incorrectly, that would be a type 1 error. So we could have made a type 1 error. Okay, so if we decided, if our data showed that the multivitamins improved memory, but they really didn't, right? So we decided that multivitamins improve memory when they actually don't. Okay, what's the consequence of that? Let's see, people could be spending extra money that they don't need to. People spend money on vitamins that don't help the memory. Cool? Okay, so something like that. All right, and then on to our second page on the back. So on this one, we're going to be just going through what are the main steps of our 4C, going through each one of those. So in our first one, remember the first thing we do is we choose. So what is happening here for choose? We are choosing what type of test this is. So this is a 2-sample t-test for mu1 minus mu2. And again, that's because we got them from 2 different populations at 2 different places, the 2 different colleges or universities. Okay, then we go into check, and the big thing here that we are checking is we are looking for independent or random samples. Independent random samples. Again, this usually means we're just looking for the word random and quoting it, and if we can't get random samples, we're looking for random assignment. That's what's going to tell us that it is an experiment. And then we are also looking for the 10% condition, and then we're going to write unless it's an experiment, and then we skip that step. And then our last one is our normal or large count. And then don't forget to check that. I'm going to say times 2 for both populations. Okay, next up would be our calculate. So our calculate is going to be our t equals x bar 1 minus x bar 2 minus mu 1 minus mu 2, which should always be 0. And then they're going over the square root of standard deviation 1 squared over n1, standard deviation over 2 squared over n2. Okay, and then don't forget under this one to not only calculate t, but to also draw the picture. So we draw the picture. We also write our probability statement, right? That's the one that starts out with p, and then t is less than or greater than whatever the amount is. And then we also do our calculation for degree of freedom around here. Okay, and I think that's it, and we get our p-value out of this. Okay, and then lastly, our last thing that we do is our conclude. And remember, in conclude, we have 3 basic things. The first thing we do is interpret p-value. The next thing we do is we make a decision. And then the last thing we do is we write our conclusion. So if you want to think about this, this is kind of like ABC. We start out with assume the null hypothesis is true. That's the starter for your first one for the p-value. Then the second one starts out with a B, because, and we talk about the p-value. And then sadly the last one is we do or do not, right? So we do or do not, but we can call that one conclusion and get a C out of that to help us. Conclusion. So at least we know the first 2 sentences start with an A and a B to get there. All right, so according to Stanford Business article, Americans may eat fewer calories at restaurants if the calories of the food items are labeled on the menu. To investigate, researchers compared Starbucks from locations where the menus were labeled to receipts from stores to the menus were not labeled. We have a random sample of 30 from the stores with menus, and then they told us what their average and their standard deviation is. And then here's our second group. Then we have a random sample of 40 from stores without menus labeled with the average and what their average and standard deviation. Then here's our magic word again. Is there statistical evidence? If our answer is a yes, no, you're doing a test, not a confidence interval. Okay, and then they said assume all the conditions have been met. Okay, so if I'm doing the choose step here, the first thing is what am I running? This is still a 2 sample. This is a t test, and it's for mu1 minus mu2. What else can we put here? We can tell them the alpha level is going to be set to 0.5. We can give them what our calculation so far has been. And in this case, it's going to be an average number of 225 minus 265, which is negative 40. Let's write our HO and our HA. Both of these are going to start out with mu1 equals mu2. That's going to lead us to mu1 minus mu2 is equal to 0. And then on the second one, we are looking at, is there convincing evidence that the ones with the labeled menu, that was the first one they gave us, is less than. So that's a less than. So when we move them over and subtract, it's a less than. Okay, and it looks like we do have some evidence of a less than, because we're getting a negative value so far, right? And the negative 40 is less than 0. Okay, so next step is we're going to go and check our conditions, but they said we can assume they've been met. So we say assume met and continue on. And then our next one is our calculate. So in our calculate, I'm going to just go down straight to the formula. And our formula would be negative 40 minus 0. And then we're going to go do the standard deviation. So the first one was 100 squared over, how many in the first group? 30. And then the second one was 75 squared, and in that group there was 40 people. Okay, so that's going to give us about a negative 1.84 test statistic. Now it's a t instead of a z-score. Okay, then we go over here and we draw it. And now we can just say that this is a t distribution with a degree of freedom of It's going to be 29, but I got to go show that somewhere. So remember, degree of freedom is n minus 1 of the lower group. And our lower group was 30. So that's where we're getting our 29 from. So as a t-score, t equals 0 would be here. And t equals negative 1.84. And we're coloring in on this side. Okay. And what else do we do in this section? We want to calculate the p-value. So we need our probability statement that t is less than 1.84. And that's going to be t CDF. And this time we're starting at negative infinity, right? Because we're starting from the far left. We're going to go all the way up to negative 1.84. And then they just want degree of freedom is 29. Okay, so if I plug that in, t CDF from negative infinity, comma, to negative 1.84, comma, with a degree of freedom of 29. And I am getting a p-value of 0.038. So there's our p-value. All right, and then lastly, we are on to our final part, which is our conclusion, right? Conclusion. So we start out with assuming our null hypothesis is true. There is a 0.038 probability of getting an x bar 1 minus x bar 2 of what we got, which was negative 40 or lower. Oh, we didn't say what null hypothesis is true. Null hypothesis would be that the two mu's subtract to equal 0. So, or lower by chance alone. Okay, then here's our B sentence, because our p-value, which is 0.038, compare it to your alpha level, which is 0.05. This is going to be a less than. We reject HO, and then our last part, and we do have convincing evidence of whatever it was that they were asking, of labeling the menus, that labeling the menus reduces calories. Okay. I'm noticing that I wrote a probability statement. I'm wondering if I did that on our first part. It looks like we are missing that. So I'm going to go back there and just add that in real quick. So this would be our probability that t is, and according to our picture, it's greater than 2.25, which would be t CDF starting at 2.25, going up to infinity with a degree of freedom of 1780. That's where we're getting our oh, there it is again. That's where we're getting our p-value for that one. So I often forget the probability statement. That should be there too. That leads to your p-value. Okay. And then remember, you can check this on your calculator by putting this all into your calculator and just verifying that you're getting the same numbers. Remember that your calculator will use a different degree of freedom. There is a more complicated, more accurate degree of freedom calculation your calculator will do automatically. You are welcome to use that. Just if you use it, you say by calculator calculation, you know, something about that you got it from the calculator. Okay, otherwise they're looking for you to just do n minus 1 of the smaller one. So if I try to go and do this one and do a test and do a 2 sample t test, and I tell it I want to put in stats, and the stats that I want to put in are 225 with a standard deviation of 100, and there being 30, and then the other one being 265 with a standard deviation of 75 and an n of 40, and we wanted it to be a less than. And then pooled is always going to be no unless it's a proportion problem, and then a calculate. And when I do that on the calculator, it's going to give me a degree of freedom of 51.778. Okay, so again, the lower the degree of freedom, the more conservative you are anyway, so we're still good. But there's nothing wrong with using the calculator degree of freedom. And this time it told me my p-value this way would be a 0.036. So you see I'm off just by a very little bit at the end, still close enough to call it good. And my t on this one would be negative 1.837, and I did 8.4. So that's probably the rounding error that we're getting, is just by me rounding a little bit too much at the beginning. All right, hope that helps. Go on to your homework.